Okay, let's continue solving systems of linear equations. Here's a system, negative 6x plus 2y is greater than 5, and y is less than or equal to 3x plus 1. I notice right away that I can graph the second equation because it's already in our favorite form. We know that y is less than or equal to 3x plus 1 is going to be a solid line because of the inequality. We know that it has a y-intercept at 0, 1 because that's the b value from mx plus b. And we know the slope is equal to 3 over 1. So we're going to go up 3 and over 1. So since we already have this information, hey, let's graph this one first. So let's find our y-intercept, 0, 1. And then pretend that's a solid dot. It's just on the computer, it's a little weird. Then we're going to go up 3 and to the right 1. And then down 3 and to the left 1. Up 3 and to the right 1. Don't know why that dot disappeared. And down 3 to the left 1. Remember, this is also a solid line. So do our best to make a solid line. And now to decide where we are going to shade. So we want to find a y value that is smaller than or equal to the y-intercept of 1. So where can we find a y value that's smaller than or equal to the y-intercept? For example, like 0 works. My line's a little off, but 0 is less than 1. Negative 2 works. Negative 2 is less than or equal to 1. Negative 3 works. Negative 4, all of these values in between work. So we want to shade below our graph. We want to shade below and towards all of those y values. Now that we've got one of them under wraps, it's time to tackle the other equation. And our other equation is negative 6x plus 2y is greater than 5. I also want this in a similar format because it's so lovely to grade. So, grade graph. We can add 6x to both sides as long as we do it to both sides. We end up with 2y is greater than 6x plus 5. And I need to get y alone, so I've got to undo this 2 times y. So I'm going to divide everything by 2. Whatever I do to one side, I've got to do to the other. Y is larger than 3x plus 5 halves, which is really 2.5. So from this, we know that we have a dashed line because of the greater than. We know our intercept is at 0, 2.5. And we know our slope is equal to 3 over 1. Again, we're going to go up 3 and to the right 1. So finding our y-intercept 0, 2.5, that's right here. And we're going to go up 3 and over 1, that's somewhere up here. And down 3 and over 1, that's over here. So from my 3 points, I'm going to do my best to create a dashed line that goes through them. I want to use the lighter blue. It probably looks something like this. I should go over this solid line with this darker color. And we can see that we have some parallel lines. But we need to check the shading. So the shading on the dashed equation tells us that we need to find a y value that is larger than our y-intercept. Our y value that is larger than our y-intercept, which is 2.5. So like three. 3 would work, 4 would work, 5 would work, anything in the upwards direction would work. So we want to shade towards those values. And since we can see here in this graph that there is no overlap between the shaded regions, since there's no overlap, there is no solution. This system has no solution. No solution because the graphs have no shaded regions that overlap. So we would just simply say that we have no solution. Let's try another system. Okay. Here's the next system. 2x plus y is less than 1, and y is greater than negative 2x plus 3. Since the second equation is similar in that first example where it's already in y equals mx plus b form, let's go ahead and list all that we know and get a graph going. So for this second equation, I'm going to do this one in like red now. We know that we have a dashed line because of the greater than symbol. We know that our y-intercept is at 0, 3, and we know that our slope is negative 2, 1. So we're going to go down 2 because it's negative, but still to the right 1. So I'm going to mark my graph and go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and we can create a pretty nice dashed line. Okay, that dashed line totally blows. Psych. It's harder to do than you would think on a computer. Here's, our dashed line that goes through these points. Okay. And we want to find a y value that is bigger than the y-intercept. So the y-intercept's here at 3, 4. 4 is bigger than 3. 5 is bigger than 3. So I want to make sure I shade towards those y values that are larger than the y-intercept. So there's my first one. The second one I'm feeling a little crazy. I'm feeling like I'm going to use the color purple, all right? 2x plus y is greater than 1. I can subtract 2x from both sides, and I will end up with y is less than negative 2x plus 1. Here, we know that we're going to have a dashed line as well. We know we're going to have a y-intercept at 0, 1, and we know we're going to have a slope of negative 2, 1 again. So slope, meaning we're going to go down 2, but to the right 1. So let's start with our y-intercept. Go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. You know, we might as well go up 2 into the left 1 to get a nice little dashed line going here. And then we're going to make sure our graph goes through those points. Now for our purple one, we need to make sure that our graph, that our y, we've got this. We've got y is less than positive 1. We want to shade and find a y value that is smaller than positive 1. So like 0 would work, negative 1 would work, negative 2, heck, negative 3.5, who cares? Any y value that is smaller than our y-intercept will work. So we can see that those are below the graph. If it's less than, it's below. And again, we have no solution. We have no solution because there is no overlap between these two systems. If there was, we would just select a point in the overlapped region to say that that is one of our infinitely many solutions.